Hello, honor students. This is part five of our video to review for the test. So first of all, if we want to find the area of this triangle right here, let me zoom in just a little bit. If we want to find the area of this triangle, we take 1/2 AB area. Take 1/2 AB times sine of C. All right. So what I'm going to do is I'm going to take let's see, A times B. The sides have to be on either side of the angle. So 12 times 30 times the sine of 65 degrees. Now our calculators figure that out. 12 times 30 times the sine of 65. And you get about approximately 326.3 square units. So whatever the units would be, that's what you'd use right there. So, all right, and again, make sure your mode is in degree mode when you're doing this. That's very important. All right, next, want to find the length of the missing side. So first of all, I need to know whether I use law of sines, law of cosines. I don't know an opposite side or angle, so I have to use law of cosines. That would be a squared equals b squared plus c squared minus 2bc times cosine of a. And let's say if this is my a I'm trying to solve for, this would be my angle A, this would be my b and c. So I'm going to take a squared is equal to 7 squared plus 92 squared minus 2 times 7 times 92 times the cosine of 115 degrees. Now it doesn't matter which one is B or C, but it does matter which one is A here. So the nice thing about this problem is I can put this all in my calculator at the same time. I can take 7 squared plus 9 squared minus 2 times 7 times, oh, I'm sorry, that's 92 squared. Whoops. Made a little mistake there. All right. 7 squared plus 92 squared. Oh, I gotta delete this on my, here. Let's try it again. 7 squared plus 92 squared minus 2 times 7 times 92 times the cosine of 115, and I get a squared is equal to 9,057.3. Now I do have to take the square root because that is a squared. So I get a, let's see, take the square root of the answer there. And I get a is approximately 95.2 feet. Again, so that's a length. I make sure to put the correct units down there. All right? All right, next problem here. All right, we have a plane A, plane B, and a tower. We know these angles are correct, and we know the side. We want to find the distance between plane B and the tower and between the two planes. So first of all, I know an opposite side, opposite angle. So that means I'm going to use law of sines. Law of sines is the sine of A over A equals the sine of B over B equals the sine of C over C. Now it doesn't matter which one's A, which one's B, it really doesn't matter. I'll call this A, but if this is big A, then this side has to be little a. If this is big B, this has to be little b. And this is big C, this is little c. Again, you can label them different ways, and that's okay. So I'm going to zoom out just a little bit. All right, to find the distance between plane B and the tower. So plane B and the tower would be this side right here. So I'm going to put sine of 75 degrees over A, which is what we want to find, equals the sine of 40 over 3,500. Now you can only have one variable here. So what I'm going to do is I'm going to cross multiply these two. Then I'm going to divide by the sine of 40. So let's try that. 3,500 times the sine of 75 in parentheses. Then divided by the sine of 40. Make sure you put parentheses around there. And I get A is approximately 5,259.5 feet. the length between those two towers. All right. Next, I'm going to use, I'm still going to use my b's here. I'm going to take the sine of 40 over 3,500 equals, now I want to figure out the distance between the two planes. I want to figure this one out. Equals the sine of 65, which is across from the side I want to get, over c. Same type of thing here. I'm going to multiply these two, and then I'm going to divide by the sine of 40. So let's try that. 3,500 times the sine of 65 divided by the sine of 40. And I get c, or the distance between the two planes, is 4,934.9 feet. And those are honors problems, and that's the rest of your test review. Good luck, and go Big Reds.